All right, now we're moving on to 6.2. Now 6.2 is similar to 6.1, but there's a big difference. If you notice, when we did 6.1, when we look at these equations, you see the inverse trig function was in the equation when we started. Like here we said theta is the inverse sine, y is the inverse tangent, y is the inverse secant, theta is the arc cosine, y is the arc sine. So the inverse trig function was in the equation when we started. On those, we had to see which one quadrant, there was one answer on each. Right? Now, these are different now because now the equations, notice they have the trig function in there, not the inverse trig function. So sine theta, sine x, tangent, tangent squared, etc. To me, it's like, and I have that on your thing, it's like if I give you a problem and I say, y is the square root of 4, well, your answer is 2. Because that means the positive square root of 4 is 2. Now, if I give you the equation and say y squared equals 4, you're going to square root both sides, and then you don't know whether it's a positive or a negative, so it's plus or minus 2. So when you had to square root both sides, we didn't know, so there was 2 answers, plus or minus. When they just told us find the positive square root, there was 1 answer. These are the same way. On those other ones, the problem told us to take the inverse sign. So we knew if it was positive, it was in the first quadrant. If it was negative, it was in the fourth quadrant. Okay, now these, we're going to have more than one answer on almost all of them. Okay. Now, there's three different things depending on the trig function you have. If you have inverse, well, let's start with inverse cosine. We've actually done inverse cosine before. Remember when we finished up that one worksheet where we did the part B's, where we had to do the inverse cosine of both sides, or the last part of that application worksheet where we did the inverse cosine? That's exactly what we're doing there, the same thing here. Remember, after we took inverse cosine, we put a plus or minus in front, because like if it was positive, it was in the first quadrant or the fourth quadrant. If it was negative, it was in the second or third. And then we put a plus 360k or a 2 pi k on the back because we could go over a period. That's still what we're going to do with cosine. It's the easiest one. That was one of the reasons we used it on all those application ones. Inverse sine is probably the hardest one. Because inverse sine, you have to put it in 2 quadrants. Because you know sine is positive in quadrant 1 and quadrant 2. So you'll have to find an angle in each of those quadrants. It's negative in quadrant 3 or quadrant 4. So you'll have to put the reference angle in those 2 quadrants. Then you'll add the 360k or 2 pi k. Okay, so those all have 2 quadrants. Cosine is easy because of the plus or minus. But sine, you'll have to think about the 2 quadrants. Tangent only has 1 quadrant because the normal period for tangent was pi or 180. So because of that, in tangent or in inverse tangent or inverse cotangent, we just need 1 quadrant. We know it's positive in quadrant 1, negative in quadrant 4. And we're just going to add 180k or pi k, again, because that's the normal period for those. Okay? Now, there's some steps on here to follow. If you only see one trig function, first you want to isolate the trig function, just like we would in a regular problem. You'd isolate the x. Then we're going to take the inverse trig function of both sides and then solve it from there. So like this one here. If you look at this one, 2 sine theta minus 1 equals 0. This part here is we wait to do that for our final answer. So here there's just one trig function, sine. We need to isolate it. So we're going to add 1 to both sides. And then divide both sides by 2. So we isolated the trig function. Now the next thing is take the inverse trig function. Well, here we have sine. To get rid of sine, we're going to do the inverse sine. Because that way, if you take the inverse of a normal function, it cancels out. So now we have theta equals the inverse sine of 1/2. And remember we talked the other day, this means what angle has a sine of 1/2? Well, if we think about our triangles, we're in degrees, so we think about our triangles. That means opposite is 1, hypotenuse is 2, so the other side is radical 3. So there's our triangle. So that means, let's see, the angle opposite the one side is 30, so that's our angle. So here, our reference angle is 30 degrees. Now our sine was positive, we need to put that in two quadrants. Well, sine is positive in the first quadrant, so one of our answers is 30 degrees plus 360K. Sine is also positive in the second quadrant, so if we go in the second quadrant and put 30 degrees here, this whole angle would be 180 minus 30, so that's 150 degrees plus 360K. So again, our reference angle was 30. We found that because what angle has a sine of 1/2? Then sine is positive in the first, 30 degrees. In the second, 150 degrees. Okay? Now, the last thing we have to do is find all the possible answers. We want to find all the answers between 0 and 360. So just start with them one at a time. 30 degrees. Is that between there? Yes. So one of our answers is 30 degrees. What if we added 360? Now, remember, that's what this K number means. We can add 360 as much as we want. Well, that's 390. That's too big. Not an answer. Let's move to this one, 150. Is that between 0 and 360? Yeah. So 150 degrees is an answer. What if we add 360? 510? Too big. So this one only has two answers. So when you get done with your angle, that's your reference angle. You put it in the two quadrants, and then you have to see all the possibilities there. Okay? So that's what you do if there's only one trig function. You isolate it and go from there. Like, let's look at this one down here. Again, one trig function. So first we want to isolate it. Well, we're going to divide both sides by 2. So the cosine of x over 2 equals 1/2. Now to get rid of cosine, we do the inverse cosine of both sides. So this cancels. Now we have x over 2 equals the inverse cosine of 1/2. Well, what angle has a cosine of 1/2? Notice we're in radians here. You can tell that for two reasons. One, when you see an x, you're in radians, but here notice our range is 0 to 4 pi, so we're in radians. So if we think of our triangle, let's see, cosine is adjacent over hypotenuse. Let's see, so the other side would be radical 3. Well, what angle is opposite radical 3? Well, that's 60 degrees, or pi over 3. So here, x over 2 equals pi over 3. Now remember, for cosine, two things. We put a plus or minus in front, and normally we put a plus 360k. Here we're in radians, so we're going to plus 2 pi k. So on that step where you do inverse trig function, here inverse cosine, for inverse cosine you put a plus or minus in front and a 2 pi k in the back. Okay. Now we still haven't solved for x, so we need to multiply both sides by 2. You're going to multiply everything here by 2. So plus and minus, that's going to be 2 pi over 3 plus 4 pi k. See, we just multiplied each one of these by 2. Okay? Now we need to see, there's our answers. What fits between 0 and 4 pi? Well, let's start with 2 pi over 3. Is that between there? Now that's 0. Let's see, 4 pi would be 4 times 3. That'd be 12 thirds. Well, 2/3 is in there, so 2/3 pi is one of our answers. What if we added 4 pi? Again, that's 13 or 12 thirds. 12 thirds plus 2/3 is 14 thirds, too big. So that's the only answer there. Let's try a negative 2/3. Well, this only goes down to 0, so negative 2/3 doesn't work. But what if we add 12 thirds? Again, 4 pi is 12 thirds. If we add 12 thirds, that's 10 thirds. Well, 10 thirds is between 0 and 12 thirds, so that's an answer. If we added 2 pi again, if we added another 12 thirds, that'd be 22 thirds, way too big. So those are our two answers. Okay, that's what you do if there's a single trig function. Isolate it, take the inverse trig function of both sides, find your answer, then figure out which quadrants. All right? Now, what if there's more than one trig function? So it's the second options here. If there's more than one trig function, you want to get it equal to 0. See if you can factor it. If you can, set each factor equal to 0 and then take the inverse trig function and solve. So like this one. See, it's got a sine x tangent x over here and a sine x over here. That's more than one trig function. So let's get it equal to 0. Let's subtract sine x to the other side because we want to get it equal to 0. Now let's see if we can factor. Remember, the first thing you look for in a factor is there a common factor? Do these have anything in common? Yeah, they each have a sine in them. Let's factor out a sine x. So if I take this one divided by sine, I'm left with tangent. If I divide this one by sine, I just have 1. So it looks like that. We factored it. Now, just like we would in algebra, set each of those equal to 0. So sine x equals 0. Tangent x minus 1 equals 0. Now we have two equations to work with. Now this one just has a single trig function. So we isolate it. It's already isolated. So now we take inverse sine, both sides, to get rid of that sine. So we have x equals the inverse sine of 0. Remember, this means what angle has a sine of 0? Remember, sine is y over r. Well, when does y over r equal 0? Doesn't that equal 0 when y equals 0? Well, let's see. If you think of our 4 points, this is the point 1, 0. This is the point negative 1, 0. So doesn't y equal 0 at 0 and at pi? So this one we get 0 plus 2 pi k and pi plus 2 pi k. So we get two answers for that one. Okay, again, this is what angle has a sine of 0. We know sine, once you see 0, you know it's a quadrantal angle. That's the only way you can ever get 0 if it's quadrantal. We know sine is y over r, so that's going to equal 0 whenever y equals 0. Well, if you think of our 4 points, y is 0 over here and over here. So this angle is 0, this angle is pi. So those are the two answers there. Okay, let's look at this one. See a single trig function, just tangent. Let's isolate it. Let's move 1 to the other side. So we isolated the tangent. Now we need to take the inverse trig function. We're going to do inverse tangent, both sides. That cancels that out. So x equals the inverse tangent of 1. Again, remember, this means what angle has a tangent of 1? Well, if we draw a triangle, tangent is opposite over adjacent, so that would be 1 over 1. Is that one of our triangles? Yeah, if that's radical 2, that's a 45-degree angle, which in radians is pi over 4. So x equals pi over 4. Now remember, for tangent, inverse tangent, we just need one angle, so we have pi over 4. And then we're going to add pi k, not 2 pi k. All right? We solved both of them. Now we need to find the answers that fit. So let's just go one at a time. Let's start with 0. Remember, this bracket means 0 is included. So 0 is one of our answers. How about if we added 2 pi? Well, 0 plus 2 pi is 2 pi. Notice this has a parenthesis, so 2 pi is not included. So that's not an answer. Let's move it down to this one, pi. Is pi in between there? Sure, pi is between 0 and 2 pi. How about if we add 2 pi? Well, pi plus 2 pi is 3 pi, too big. Let's move over here. Pi over 4. Is pi over 4 between there? Yes, it is, pi over 4. How about if we add pi? Well, if we think of pi as 4/4, 1/4 plus 4/4 is 5/4. Is that between 0 and 2 pi? Yes, it is. So 5/4. If we added 4/4 again, that'd be 9/4. Well, 2 pi is 8/4, so 9/4 is too big. There's our 4 answers. Okay? Another one with more than one trig function. This one, notice we have tangent, but this one's a tangent squared, and this is a plane tangent. That counts as more than one. So same rule we just talked about. Get it equal to 0. It already equals 0. Now see if you can factor it. Now if you look at this, this is a quadratic because we have a squared, we have a single, and we have a constant. So this might factor like this. So two factors of tangent squared are tangent x and tangent x. Two factors of a -2 that when you add them you get a +1. Well, that'd be like a +2 and a -1. So we have a factor. Now we set each factor equal to 0. Tangent of x plus 2 equals 0. Tangent of x minus 1 equals 0. So if we look at this one, there's a single trig function. We want to isolate it, so let's move the 2 to the other side. Again, once you're to this step, it's like each equation is its own problem. So we have this. Now if we take the inverse tangent of both sides, gets rid of that. We have x equals the inverse tangent of a -2. Well, if we think of a triangle, this would be a triangle where tangent is opposite over adjacent. Let's see, that means our other side is radical 5. That's not one of our triangles. So when we get ready to do tangent here, we're going to do that on our calculator. What that E is out there for, it's not supposed to be there. So on your calculator, you want to make sure that our mode looks like this one is in radians. So we want to make sure our mode is in radians, so change that. Now we're just going to do inverse tangent of -2. So we go second tangent, -2, and I get -1.107. So we have x equals -1.107 plus pi k. Remember on tangent, we just need one answer, and we're going to add pi k when we're in radians. Okay, let's do the other part. Here in this one, I see a single trig function, so we want to isolate it. So let's move the 1 to the other side. Let's do inverse tangent. Gets rid of that. Now we have x equals the inverse tangent of 1. Well, if we think of a triangle again, tangent is opposite over adjacent. Well, we did that one before. That's that triangle. So x is pi over 4, because that's a 45, 45, 90. So x equals pi over 4 plus pi k. So now we have these two things to work with. We want all the answers that are between 0 and 2 pi. Let's start with this one this time. Let's start with pi over 4. Is that between 0 and 2 pi? Yeah, because 2 is 8/4. If we add pi, you can think of pi as 4/4. If I take 1/4 plus 4/4, that's 5/4. Well, that's smaller than 2. If I add 4/4 again, if I add another pi, that'll be 9/4. Well, 2 pi is 8/4, so that's too big. So it's just those two from there. Now this one, if we start with -1.107, well, that doesn't fit because we only go down to 0, no negatives. So now if we take that number, now I happen to still have that on my calculator, we can add pi to that. Well, let's hit plus pi. I get 2.034. Well, is that between here and here? Remember, pi is 3.14, so times 2, that's like 6.28. Well, we got 2.03. Well, that's in between there, so one of our answers is 2.034. What if we add pi again? So while that's still on your calculator, hit plus pi. I get 5.176. Well, that's smaller than 6.28, so that fits, 5.176. If we add pi again, so add pi. Now I get 8.317. Well, we're only going up to 6.28, so those are our 4 answers. Okay? Let's look at this one. Here again, there's more than one trig function because there's a cotangent and a cotangent squared. Again, if you look at this, this is a quadratic, squared, a single, and a constant. So let's see if we can factor it like this. Let's see, if you look at that, cotangent and cotangent, are there two factors of 1 that we can add together and get 3? No, there aren't any. So this one doesn't factor. So we're going to use the quadratic formula. So this is A, B, and C. So to use the quadratic formula, we start with cotangent theta equals, because that's our variable, cotangent theta equals negative b, so negative 3 plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 2. So if we get the quadratic formula, we get that. Let's see, that's negative 3 plus or minus the square root of 5 over 2. Well, looking at that, we know cotangent's adjacent over opposite. There's no way that's one of our triangles. Let's use our calculator on this. So we have two answers, negative 3 plus radical 5 over 2, negative 3 minus 5. So let's see what we get. If I take a negative 3 plus the square root of 5 and divide it by 2, I get a negative 0.381. Actually, I'm sorry, let's round that off to 0.382. Let's do the other one where it's negative 3 minus the square root of 5. So negative 3 minus the square root of 5, divide that by 2, I get negative 2.618. So we had to do that apart on our calculator there. Now notice this is cotangent. Well, we don't really like cotangent. We don't like the reciprocal functions. Let's look at the tangent. Let's see, we know the tangent is the reciprocal of cotangent, so it could be 1 over a negative 0.382 or 1 over a negative 2.618. Now to get rid of tangent, let's take the inverse tangent of both sides. So 1, if I take this top one, I'm going to take the inverse tangent of 1 divided by a negative 0.382. You can see that on there. The inverse tangent didn't show up very well. Inverse tangent of 1 divided by a negative 0.382. Let's see. Since it says theta here, we want to be in degrees. So before I do this, I'm going to hit my mode and make sure to say degrees. Remember, we talk, whenever you see theta, you're in degrees. So I want to make sure I'm in degrees. Now I'm going to do the inverse tangent of that reciprocal. I get negative 69 point something. So for that one, I get negative 69.093. Remember, cotangents like tangent, we only add 180k since we're in degrees. Okay. Now let's do the second one. Let's do the inverse tangent of 1 divided by a negative 2.618. I get negative 20.905. So negative 20.905. Okay. Now we're going to add 180 to each one of those. So if I add 180 to this one, 180 plus a negative 69.093. Oh, I'm sorry, one thing here. Notice when it says for all solutions, that sounds like a lot of work. It's actually less work. When you get one that says for all solutions, as soon as you get to this step where you solve for theta or y, you're done. Because this way we can find as many answers we want. We can keep adding 180 as many times as we want to. So whenever it says for all solutions, you really like that to happen. Because that means once we get to right here, we're done. We don't have to find what fits. Okay? Let's see. Now look at this one. This one has a sine and a sine, but this one is an x and a 2x. Because the angles are different, this counts as more than one trig function. Now when it looks like that, you need to think, okay, sine of 2x, we have an identity for that. That's a double angle identity. Well, the sine of 2x, the identity for that is 2 sine x cosine x. So let's make that substitution. because we don't like it when the two angles are different, x and 2x. Well, now there's still more than one trig function. Let's get it equal to 0. So let's move stuff to one side. Let's say I move this to the left. So I have sine x minus 2 sine x cosine x equals 0. Now once we get it equal to 0, we see if we can factor. Remember, we always look for a common factor first. Well, they both have sine in them. Let's factor out a sine. So here, sine divided by sine is 1. A negative 2 sine x cosine x divided by sine gets rid of the sine x, negative 2 cosine x. There's our two factors. Now we set each one of them equals 0. Sine x equals 0. 1 minus 2 cosine x equals 0. Now we're going to do each one separately. Here we have a single trig function now. We isolate it. It's already isolated. So let's take the inverse sine of both sides. Get rid of that. We have x equals the inverse sine of 0. Well, we did that one before. Remember up here we had the inverse sine of 0. So that means what angle has a sine of 0? We decided that happens at 0 and at pi. Here we're in degrees. So that means it happens at 0 degrees and at 180 degrees. We're going to add 360k. Okay. So let's go on to this one. Again, we have a single trig function. Let's isolate it. Let's move the 1 to the other side. Let's divide by negative 2. Okay. Now, what angle has a cosine of 1/2? We did that right up here. What angle has a cosine of 1/2? We looked at the triangle like this, when the adjacent side is 1. That was a 60-degree angle. So here, we have x equals 60 degrees. And remember, for cosine, we put a plus or minus in front and a plus 360k in the back. Okay. Now we need to find what fits, because here our domain is between 0 and 720. So let's just do one at a time. Let's start with 0. Is that between there? Yeah, we have a bracket, so 0 is included. How about if we add 360? 0 plus 360 is 360. That fits. How about if we add 360 again? That'd be 720. Doesn't quite fit because of the parenthesis here. So we have those two from there. Let's go down to this one, 180. Is that between there? Sure, 180. How about if we add 360? 540? Yep, that's in there too. Add 360 again, 900, too big. All right, let's go to this one, 60 degrees. Does that fit? Yeah, 60 is between there. How about if we add 360? 60 plus 360 is 420. That fits. How about if we add 360 again? 780. Oh, too big. Let's go to negative 60. Does that fit? No. No negative numbers. How about if we add 360? Negative 60 plus 360 is 300. Does that fit? Yep. How about if we add 360 again? 660. Does that fit? Yep. How about if we add 360 again? That'd be 1020, up too big. So we have 8 answers for this. So on these, you want to follow these steps that are up here. So what to do if there's a single variable, or a single trig function, isolate the trig function, do the inverse trig function, solve it, find what fits. There's more than one, get it equal to 0, see if you can factor it. If it won't factor, if it's a quadratic, try the quadratic equation. If you can factor it, if the angles don't match, try one of the identities. Remember that mostly have at least 2 answers. Most of these had 2 answers. There was one with 4, one with 8. There could be lots of answers on this. Okay, that's 6.2.